All right, guys. So now it's time to move on to some questions where you actually learn how to apply all these theories that we proved. So you need to be able to use them in sums. So now let's see how to use these results. Okay. So first I'll go through an example. So this is the example number 12. So let me explain to you how that works. And okay, so let's see how this works first. So they say, find the position of the center of mass of the frustum of a right circular uniform cone of end radius 1 centimeter and 4 centimeter and of height 7 centimeter. So guys, first of all, what is a frustum? So when they use the word frustum, they expect you to know what it is. So what do you mean by a frustum? A frustum is something that you create by taking a large solid cone. You take the cone and you cut off a part of the cone. Now you can see here I have taken this cone and I'm cutting the top part of the cone. Can you see? And then the resulting object, it looks like a lamp shade kind of like, but I think this is completely solid, right? Okay. But so you kind of get this shape. Can you see where you remove the top part of the cone and the remaining object that you have over here is what we call as a frustum. All right, guys, do you agree? So this is what they call as a frustum. So in a frustum, there are end radii. End radii is because there is a circular face on top and there is a circular face at the bottom. Do you see there's a circular face at the top and there's a circular face at the bottom. So one circular face has radius 1 centimeter, the other one has radius 4 centimeter. All right, and the height of the frustum is 7. So can you see I've marked everything on my diagram? So I have a 1 centimeter radius, a 4 centimeter radius, and the height of the frustum is 7 centimeter. All right, guys, can you see? All right, so now the thing is, we are supposed to find the center of mass of this shape. So this is what you need to find the center of mass of. Okay, so that's your task. So the thing is, I mean, this is not a shape that we immediately know to find the center of mass, right? So we don't immediately know how to find the center of mass of such an object. So what we're going to do is we are going to break this up. We are going to use the previous technique now. We are going to draw a table and we are going to divide this into, the objects that we know. So how do you create the frustum? And you can see we have a large cone. From the large cone, we remove the small cone, right? Can you guys see? So I'm actually creating a table here. Right, guys? Can you see? So from the large cone, all right, guys. So from the large cone, I'm removing. So you can see I have used a subtraction sign. Now just don't go through all the working. I'll explain you the working. So from the large cone, you remove the smaller cone and you get the frustum. Is this clear? So that's what I want you to understand first. Okay, this is what I want to understand first. Okay, so now let's actually go through the working. Okay, so how do we go through the working? Mass. So first thing is in this table, object mass, center of mass. So how do we get the mass? You get the mass by taking mass is proportional to the volume, right? So in 3D objects, mass is proportional to the volume. So, how do you get the mass here? The mass of a cone or volume of a cone is 1 over 3 pi r square h. So, these are stuff that you need to remember. You need to know volumes of 3D objects, volume of cones, volumes of hemispheres. So, you can see I've been using those stuff a lot. Okay, so you must remember the volumes of these 3D objects. Okay, the volume of a cone is 1 over 3 pi r square h. And why have I multiplied by rho? Because in order to convert volume to mass, you have to multiply rho is the mass per cubic unit. All right. Okay, and guys, you can see what I've done over here. 1 over 3 pi. Radius of the large cone, I think we can clearly see radius of the large cone is 4, right? Radius of the large cone is definitely 4 centimeters. That's fine. Okay, and then into height, guys. What about the height? Now I have used the height over here, but how did I get this value? Okay, how did I get this value? How do we get the complete height of the large cone? I think you can see if you look at this shape, they have not mentioned you the height of the cone. Can you guys see? You don't have the full height of this cone actually. Okay, they've given you the height of the frustum, but you don't have the height of the cone. So this needs to be found. Okay, this height needs to be found. How do you find the height? So you need to do some work before you come to this table actually. How do you find the height? Right, guys. So taking a look at what I've done here. Okay, guys. So look at this working, what I've done here. So can you see what I'm doing here is you can see I'm taking this large cone and I'm actually using the technique of similar triangles. Guys, do you recall similar triangles? So if you look at this shape here, I hope you guys can see that there's a large I have drawn like in, let me show it again. Okay, so this one in like brown color, right? Can you see this is the large triangle? So you have a large triangle, and over here in green color, I'm drawing a comparatively smaller triangle. Can you guys see? So there's a large triangle and a smaller triangle, and these two triangles are definitely similar triangles because their angles are definitely the same. Right, guys? They are similar triangles, the angles are the same. So in similar triangles, we say ratios between corresponding sides are equal. Do you recall these kinds of theories? Ratios between corresponding sides are equal. So I'm first taking the smaller triangle, and you can see I have written x. X is the height of the small triangle. Can you see? X over x plus 7 is the height of the large triangle. Can you see, guys? So x is the height of the small triangle, divided by x plus 7 is the height of the large triangle. Equal. On the other side, use another length. For the other length, I have used 1 centimeter is the length on the small triangle, the radius, and 4 centimeter is the length or the radius corresponding to the larger triangle. Can you guys see how I have created this? I have used the fact that the two triangles are similar. I have used the fact that the two triangles are similar. This is x, this is 7. So total height, so x over x plus 7. X is the length of the small triangle. X plus 7 is the length of the large triangle. And then small triangle length here is 1. The other one is 4. So 1 over 4. So you create a ratio like this. And this is done for similar triangles. All right, guys. So this is really important. And then I cross multiply and I get my x value and I get x as 7 over 3. Can you see, guys? So then if x is 7 over 3, the total height. Now the thing is, I want the total height of the large cone. The total height is x plus 7. Isn't it, guys? X plus 7. 7 over 3 plus 7. And that's how I'm getting the value of 28 over 3. Okay. Yeah, and there's a suggestion that we can even use the tan ratios. That's also correct, right? Because if you write tan theta for the small triangle, that's another method actually. That's another easier method. Tan theta is opposite over adjacent. So 1 over x for the smaller triangle. And if you consider tan theta for the larger triangle, it's 4 over x plus 7. And then you can, because it's the same theta, right? For both the triangles, it's tan theta value is the same. So tan theta ratio is constant. So you can say 1 over x is equal to 1 over x is equal to 1 over x is equal to 4 over x plus 7. Yeah, you can definitely do this. Right, guys? And again, you should get x as 7 over 3. You will get x as 7 over 3, guys. If you try this method also, that works. I believe that might be easier. If the similar triangle technique is too long, you can go with the tan theta method. So I believe this might be easier, right? Do you want me to complete that? So in that case, I get here 1 over x equal 4 over x plus 7. So I get here x plus 7 equal 4x. So 7 equal 4x minus x is 3x. X equals to 7 over 3. All right, guys, clear? That's the x value, that's the height. And then remember, to get the total height of the cone, you have to add 7 over 3 to this 7. Okay, that's what gives you the total height. And guys, that's how I got this value 28 over 3. Do you see now the height of the cone? I was using the large cone. Height of the large cone is 28 over 3. And that's how I got that particular value. All right, guys. So this is how I got 28 over 3. Okay. And radius is 4. Okay, so half r square, half pi, radius is 4 square into height is 28 over 3 into rho. So get your answer. Is that clear, guys? And then center of mass of a solid cone. So you need to recall center of mass of a solid cone is at a distance at how much of a distance? So we did this previously, right? Center of mass of a solid cone. So we've done this here. Center of mass of a solid cone is at a distance 3h over r from the vertex. That's from the vertex. But I believe in our sum, the center of mass we don't require from the vertex. I think in our one we require it from the plane face, right? Did you see in the question? our O was marked at the surface, at the plane, at the circular face, right? So we require to get the center of mass distance from the circular face, not from the vertex. So this distance is h over 4. Can you see, guys? So in our sum, the distance is h over 4, because you can see here. Can you guys see the O is, I mean, we have marked O at here. We are getting the distance of the center of mass marked from point O. Okay, so this G, the distance is, I'll just mark this as G1. So G1 distance is h over 4, right, guys? Do you see? Okay, not 3h over 4. 3h over 4 is the distance from the vertex. Okay, I am currently interested in distance from the plane face. So it's h over 4, and guys, h is 28 over 3. So 1 over 4 into 28 over 3, the answer is the center of mass is at a distance of 7 over 3 units above O. All right, guys. All right, guys. So the next part, I think you can see this is the cone that we are removing, right? The smaller cone that we are removing, because from the larger cone, you have to remove the smaller cone in order to create the frustum, right? So the larger cone, I've explained you about the mass and the center of mass. Now going for the smaller cone. So in the smaller cone, you can see the volume 1 over 3 pi r square h into rho. So once again, 1 over 3 pi, radius is 1, right? The smaller cone had a radius of 1 centimeter. We can see that clear. And what about the height, guys? Height of the smaller cone is x, right? Height of the smaller cone is x, which is 7 over 3. Can you guys see? Height of the smaller cone is 7 over 3. That's what I've used over here. Okay. And then into rho, right, guys? So rho is the mass per unit volume here. Okay, so then I get here 7 over 9 times pi rho. And the reason I'm using a minus sign here is I'm reminding myself that I need to what? When I'm doing the sigma, when we take the sigma, you need to remember from the large con, we are removing the small con. It's a removal, not an addition. That's why I put the minus sign here, just to remind, this is not needed to, you don't need to put the minus sign here, but that's just to remind ourselves that we are going to perform a subtraction, not an addition. Because from this body, I'm removing this body. Okay. So at the end of the day, when you're performing sigma mi xi equal total mass into x bar, you have to do a subtraction. Right, guys? Right, guys? Because you're removing this. Okay, so this is the mass, center of mass. Okay, now you need to be really cautious here. Okay, now remember, center of mass, you are measuring from O. Okay, we are measuring the center of mass from point O. And guys, you can see now the small cone is also having the distance of the center of mass is at a distance h over 4, right? It's at a distance h over 4 from, so this distance is h over 4. Guys, you need to bear in mind, you are taking the distance from O. So you need to understand that the smaller cone is actually above O, right? Can you see the small cone is actually above O, a certain unit above O. So guys, h over 4 here is now, of course, for h, you had to use the respective height of this particular cone. So this cone has a height of 7 over 3. So 1/4 of h is 1/4 of 7 over 3. And that gives you this small part. That gives you the center of mass distance from the plane face of the cone. Other thing is, I am supposed to give the distance starting from O. And that's why I'm adding an extra 7. Can you see we add this extra 7 because we are getting the distance measuring from O. So 1 over 4 into 7 over 3 plus that 7. And you can see I'm getting the distance as 91 over 12. Right, guys? Can you understand? You have to measure the center of mass distance starting from O. And then finally we come to the frustum. So frustum, it's pi rho. I'm subtracting these two, guys. Okay, so 448 over 9 pi rho, you subtract with 7 over 9 pi rho. It's a subtraction because you are removing. Remember, the mass is reducted. And I get here 49 pi rho. All right, guys. And then over here, I've used y bar. If you want, you can use x bar, but I think I can see it vertically, right? This is vertically staying. So I've used this as y bar. Okay, and you can see if you use this as the y-axis, then x bar will be 0. You don't need to find x bar, right, guys? Because your center of mass is definitely on this line of symmetry. Do you understand? So this red color line is a line of symmetry. Right, guys? Can you see? This is a line of symmetry. Center of mass is definitely on this line of symmetry. Okay, so basically I'll say that is the y-axis. So x bar is surely 0. You only have to find the y bar because I took the vertical distances from O. All right, guys. So I hope that part is clear with y'all. And now all I have to do is apply these table values into the formula. So you know the formula sigma yi, let's say yi equal total mass into y bar. Okay, so I'm using y because we are having vertical distances. Okay, so you multiply the mass 448 pi rho multiply by 7 over 3. And then remember not a plus sign but a minus sign. That's why I even put it here. And then the mass 7 over 9 pi rho into distance is 91 over 12 equals total mass. Total mass is 49 pi rho, right? We found it here, 49 pi rho into y bar. Right, guys? Can you see? So this is the answer. And then you can see all the terms have pi rho in common. I've cut it out. And I'm remaining here with 448 over 9 times 7 over 3 minus 7 over 9 times 91 over 12 equal 49 y bar. And I brought the 49 down. And guys, to get the answer, now it's just a matter of typing everything in the cal. So if you type this all in the cal, you will get this answer. So I believe you can type this correctly, right? So type the numerator first and then get that answer and then divide by 49. All right. Otherwise, if you type everything at once, make sure you give the brackets properly and give everything at once. So, or else get the answer for the numerator first and then divide by 49 and you should get this answer beautifully. Right, guys? So this is how an example of this particular sum, how you're supposed to use the theory. So you can see I did not do any proof for the theory, but I directly use the center of mass is h over 4 from the theories that we have learned previously. All right, guys? It's clear? So this is how you do. This is how a center of mass sum, like, how it looks like. And this is how you're supposed to use the theories that you have learned. Okay, so I hope this is clear with everyone.